Hi, this is Dr. Steve Graves from the CSUN Geography Department and geographyplanet.org. This video tutorial is an extension of the previous video that showed you how to convert a point layer of crimes, in this case burglaries in the Antelope Valley, using the collect events tool, and then from there using the kernel density smoothing tool into a hotspot map, and then converting that data through a tool called zonal statistics as table to this final map, which includes as a choropleth map the average number of burglaries per census tract from 2014 to 2016. That is not a direct count, but a kind of indirect count that allows the effect of burglaries to spill across borders if they happen at the intersection of multiple census tracts. And if you zoom in, you can see that that frequently happens, and there is really almost no way to tell whether the burglary actually occurred on one side of the street or another, or in exactly what census tract or zip code that it occurred in. And so this strategy prevents a dramatic overcount or undercount of the point data. What we're going to do next is try to figure out what are the causal variables that will help explain the variation in burglary rates across the study area. And in order to do that, we are going to first attempt to execute ordinary least squares regression on the data, and that's relatively easy. But the difficult part is setting the data up so that the regression tool will run efficiently, smoothly, and logically. In the second step, I wanted to point out that if I open the attribute table, you will see that I have also added a second column of crime data here, and this is the aggravated assault mean. So what I want to do is to, that was right click and open the fields view. I want to scroll down here and change the name of this, at least the alias, to ag assault. Go up here and save. And then I'm going to come back and I'm going to uncheck area, count, zone code, ID, object ID, a bunch of these other extraneous things. I don't even really need this count one. We kept the bird count, but that's just the number of pixels per census block group in this case. And at this point, I'm going to click save, and then we won't be able to see these extraneous variables in the attribute table. So there we have the aggravated assault over here in the far right column. If I turn on the aggravated assaults, or turn this off, this is the aggravated assault hotspot map that now is appearing as a choropleth map at the block group level. So we have not just burglary rate by census block group, but now also aggravated assault. So our next task will be to once again open this attribute table, and what we need to do is to create some new variables, or identify the variables that we want to consider for our model. Population density is an outstanding one to begin with. It is a typical and reliable indicator of criminal behavior, number of arrests, that sort of thing. It makes sense because it's hard to burglarize some place if there aren't people there. So that's one that we will definitely hang on to, and because it's already a rate, a density, it's a ratio variable, we won't need to worry about it too much. What I do want to do is to right-click and bring up the statistics window, which will give us some indication of the distribution. The skewness is the data here that we're most interested in, and this skewness isn't too bad. Of course, this isn't a perfect normal curve, but it isn't too bad. It's not too far off. If we switch from population density and take a look at our burglary mean, we see once again that it is a little more skewed, but not too badly so, and our aggravated assault also slightly more skewed. All in all, none of them are radically skewed to the right or the left, and so we should be able to use all of those together harmoniously. Some of these others we won't be able to use without some modification. For example, the total number of housing units, that very well may not make any sense anyway, but if we were to calculate the percent of people who are renters, we would have to divide the renter-occupied housing by the total housing in order to get percent renters. And one of the reasons that you may want to use that is that neighborhood stability is a common predictor of crime rate. So in places where people are owner occupiers of the house, they tend to live in those places longer, and that leads to greater social stability and lower crime rates. So we will calculate renter occupied, and then these as well, Gen Z, millennials, those are also things that are probably worth calculating, because younger people age 15 to 25, particularly male population 15 to 25, another common indicator or causal variable associated with crime rate. And so we see these variables here that we can turn into percentage. The median age is something that, although it is not a ratio data type, we can use it. It has a tendency to be a good proxy sometimes for the age variable, so we'll give that a shot. And then we will calculate various percentages for Hispanics and non-white Hispanics and blacks, Asians, etc., in order to get those into percentage, so those can also be used. Those people who are victims of racism live in neighborhoods that are marked by higher crime rates. The diversity index, we may be able to use that. And here are some other variables that we'll want to calculate. Educational variables also often are useful in predictive crime studies. Income, definitely, and there's multiple ones of these. These are oftentimes a challenge if we take a look at median household income and take a look. This is actually well done. It is a median, so medians help lower the skewness because it's not an average, and because we're only taking one part of Los Angeles County, we don't see the skewing that we might see if we were including Bel Air or Malibu, places like that where the median income would be sort of off the chart. Taking a look once again at the final set of these is population in family style household. Husband and wife family households are more stable. Those neighborhoods that are marked by lots of nuclear families as opposed to single family households have a crime rate, and so that will be the last of the major ones we will consider. There may be dozens others out there that you might want to consider as well. In order to calculate a field, the first thing I want to do is add a new field, and this brings this window up. I'm going to call this percent age 15 to 25, and then we can call it percent 15 to 25. and we want this as a double and a numeric value. Don't need that many decimal places. 2 is more than enough. And then click Save. Okay, so then we go back to our table, scroll all the way to the right, and we find this new column. I'm going to right click here and make it float. I believe it will be easier to see that way what I'm doing. So I want to right click up here at the top and choose Calculate Field. This is a Python expression, so what we want to do is to add together the populations of everybody, open parentheses, 15 to 19 plus 20 to 24, close that parentheses, and divide that by the total population. We click Apply, and it should give us a percentage. We want to bring up the statistics on that once again, and we see that the skewness is low and that the kurtosis is high, so a lot of these neighborhoods are within a small range, and that is almost to be expected given that this area is largely suburban. So we want to essentially replicate this pattern of creating new columns until we have a collection of variables that we find satisfactory. Percentage of age categories, percentages of various ethnic categories, and percentage of renter occupied housing, that sort of thing, along with a percentage of people with a high school diploma or a bachelor's degree, and we should be ready to go. I'm going to work on that and then I'll come back. Okay, and so now I have created several other new categories: percent white, non-Hispanic, percent of people with a high school diploma, percent Hispanic or black. So this is sort of a doubling up of percentage of people who are, or a combination of people who are either Hispanic or black and not Hispanic. It's different than percent non-white because it excludes Asians, percent nuclear families, percent renter. And that's where we'll stop for this first half of this regression thing. So we've got a few variables ready at least to run through the ordinary least squares regression test.